come to the right spot. It's another edition of Lewis at Large. 60 minutes of smart talk radio is in your future with guests from all walks of life and all points of view. And now with this week's edition of Lewis at Large, here's your host, Warner Lewis.
Welcome back, everybody. Again, Warner Lewis from the flight deck of Lewis at Large Radio. Another fine segment here of Smart Talk Radio for you. This segment, an interesting one indeed. We're going to be talking about human disease and how it arrives in Homo sapien being transferred by animals. And you're thinking, well, no, wait a minute, what's that really all about? Actually, it's about quite a bit, and we're talking with an expert indeed. Science writer David Quammen has researched this subject for many years, has many written works about it. Specifically today, we'll be talking about a new work called Spillover, and it really talks, again, reporting animal origins of emerging human diseases. Should be an interesting topic indeed. David, how are you, my friend?
Very good. Good to be with you, Warner.
Good. Let's give our Lewis at Large listeners a little bit of background here. Tell us, you're a science writer, but it's very clear you are extremely interested in human disease and in particular how it relates also with the animal kingdom. Tell us how David Quammen arrived in that field.
Well, I was on assignment about 12 years ago for National Geographic. I do a lot of things for them. And I was sitting at a campfire in the middle of a Central African forest in the course of a cross-Congo trek, and there were two local guys, two Gabonese porters at that campfire, started talking to me about the time when Ebola virus hit their village just a few years earlier, and it had killed a lot of people, killed friends and loved ones. It was a horrible outbreak. We were sitting then not very far from their village, a little west of it in the forest, and so this was very immediate to me. And they told me one fellow lost 6 family members. He had a niece who died in his arms. They didn't know that it was Ebola at the time, but research later showed that's what it was. And one fellow said, strange, peculiar thing, when this was happening, when this hit our village, we saw nearby in the forest a pile of 13 dead gorillas. Now, he didn't know that gorillas, as well as chimps, are susceptible to Ebola just as humans are, but I knew that. And when he said that, 13 dead gorillas, that image, that phrase stuck in my head because I realized it represented the connectedness of that particular disease. Ebola in humans, Ebola in gorillas, killing both kinds of creature, and that became the starting point for this book on the connectedness of disease, the diseases that we share with other species.
I'm interested as to, and again, I don't think this discussion can happen without some reference, obviously, to the AIDS virus and that relationship. But from what you can tell in a very general sense, David, are these diseases coming from jungle animals, or are you talking about diseases born, for example, by bees or dogs or cats and common household pets?
Well, it's both. It's both. We hear about things like Ebola, Marburg disease. These are faraway problems. Those reside probably in bats in the Central African forest. They can't be living in gorillas or chimps permanently because they kill them too quickly, so they have what's called a reservoir host. But not all of these are faraway, remote problems. We've got diseases that spill over from animals into humans in this country too. For instance, we've been hearing about Hantavirus this past summer. It killed 3 people who had stayed in tent cabins in Yosemite National Park. Where did the Hantavirus come from? It spilled over from mice. Ordinary forest and backyard variety deer mice carry Hantavirus, and it spills over in their urine and their feces, and when somebody comes into a cabin or a barn and sweeps up the dust, then it's wafted up into the air. That seems to be what happened to the people in Yosemite.
I've got a question for you, just a general global one. Mm-hmm. Is it possible, does the river ever run the other way? Is there evidence that humans transmit disease to animals?
The river does sometimes run the other way. There's a memory of chimpanzees, Jane Goodall's famous chimpanzees at Gombe Forest in Tanzania, having been infected with polio during the late 60s. People are enormously concerned about the mountain gorillas, that rare subspecies of gorillas that lives on mountains in Rwanda and Uganda. People visit them. It's an ecotourism adventure. You get to go see the habituated group of mountain gorillas. You get to stay with them for an hour, but you're not allowed to get closer than 15 feet because you might give them a disease. You could give them measles if you were carrying it. You could give them a cold. You could give them potentially tuberculosis. So, yes, it does pass in the other direction, too, although we hear about it much more when it passes from non-human species into humans, of course, because we're paying much more attention to our own health than we are to the health of animals in the forest.
Okay, well, we want to talk about spillover for sure, your most recent work, but I do want to explore, and you are the guy. Talk to us about AIDS. Talk to us. Tell us the facts as you know them. How that whole thing, or at least theoretically or factually. So many people have heard so much, but I don't know they've ever heard it definitively.
Yeah, the origins of the AIDS pandemic have been shown just by scientific work in the last 4 or 5 years to be very different from what we think we know. We know now, based on molecular phylogenetics work, that which is a fancy word for studying the genomes of viruses. We know that the pandemic strain of AIDS spilled over from one chimpanzee into one human in the southeastern corner of Cameroon in Central Africa about 1908 or earlier, give or take a margin of error. Far earlier than we thought, and in a very particular part of Central Africa. From there, it simmered in the villages for decades. It didn't really catch anyone's eye. Life was hard and short, and people were probably dying of a lot of things before they could show symptoms, or they were dying of fevers, they were dying of immune failure, but nobody was diagnosing this as a new problem. It worked its way down some rivers, eventually to the main stem Congo River, and down that to big cities, the big city of Brazzaville, which was capital of French Congo, and the big city then known as Leopoldville, capital of the old Belgian Congo. And it simmered and sizzled in those cities for some more decades, and we know it was there in Leopoldville as early as 1959 because there's been an HIV-positive tissue sample found in an archive of pathology specimens. And then eventually it started to increase in momentum because sexual mores were different, the population was more concentrated, more cases, more secondary cases were developing from each primary case. In other words, people were passing it to one another more. Eventually it got out of Leopoldville to Haiti, with Haitian professionals who had come over to help the newly independent Congo, the Democratic Republic of the Congo, after the Belgians had gone home after independence occurred in 1960. Haitians came over to help out in jobs such as teaching and being engineers, doctors, middle-class professionals, and they picked up the virus. They had sexual relationships, got the virus, and then the Haitians went home in the mid-'60s, and they took the virus with them, got to Haiti, and eventually got from Haiti to the U.S. and to the world.
And this all trails back. It's fascinating to me. It can be trailed all the way back to 1908 in a very specific incident. How? It just, okay, for our Lewis at Large listeners, again, in the simplest terms that you can, how in the world can they do that? How do they know it?
How do they know it? Well, the incident itself can only be reconstructed inferentially. They can't point to the person or the chimpanzee, right. But they know by comparing the genetics of the human strains of HIV, the pandemic strain, the one that accounts for most of the AIDS pandemic, by comparing the detailed genetics of that with the genetics of the virus that is still found in chimpanzees in southeastern Cameroon, they can say, look at that, holy cow, that is the match. That is where this thing had to come from, wow. Because it is a precise match with that chimpanzee virus there.
What about, thank you. That is, there you go, Lewis at Large listeners. You've heard it from the horse's mouth, so to speak. the definitive trail. Did it take? Obviously, it took a long time to pinpoint that, did it not? Because there were a lot of theories bouncing around for a long time, weren't there?
That's right, and this work was just done in the last, as I say, 4 or 5 years. It was published in scientific journals. It was done, some of it by a woman named Beatrice Hahn at the University of Alabama. Molecular phylogenetics, as I say, they sequence the genomes of these viruses, and then they can compare them letter by letter to another virus, and that's what they did. It wasn't until within the last decade that they could get samples of the virus from a lot of different chimpanzees in the wild. It used to be that you had to take a blood sample to isolate the virus, and then you could genetically sequence the virus. But then they developed techniques whereby all they needed was a little bit of chimpanzee poop. So you could follow chimpanzees around and collect a little sample of their poop, put it in a tube, take it back to your laboratory, isolate the virus, and sequence the genome of that virus.
It's thankless work, but somebody thankfully did it. And,
somebody did it.
Again, if you just joined us, we're talking to David Quammen. He is a scientific writer written for National Geographic, amongst others. A new work called Spillover, talking about, again, the transmission of disease from the animal kingdom to humans. David, common things that we're very familiar with, rabies, encephalitis, those are those immediate kinds of transfers. Is what you're talking about something a little more indirect than just a bite, so to speak?
Well, sometimes it can be a bite going in either direction. They bite us or we bite them. Rabies is generally passed by a bite. Warner, there's a technical term for this. The scientists call it zoonotic diseases. And
right.
Rabies is a zoonotic disease. We now know that AIDS is a zoonotic disease. Zoonotics are all these things that pass from animals into humans. And they might pass when an animal like a rabid dog bites us, because the virus in that case travels in its saliva. It might be a blood-borne virus. We seem to have gotten the HIV virus from chimpanzees because somebody killed and butchered a chimpanzee and then presumably had a cut on his hand. They call it the cut hunter hypothesis, and got blood-to-blood contact from the chimpanzee's blood into his blood through a cut. It can also pass through the air. For instance, influenzas. All of the influenzas are zoonotic diseases. Sars was a zoonotic disease. Remember that it was the scary one that emerged from southern China back in 2003. So those kinds of diseases, they might drip out of an animal and get into dust the way I mentioned Hantavirus does, and then be wafted into the air and breathed in. And then once they have taken hold in the human, and this is what makes them so devastating, those particular kinds like influenza and SARS, they can be breathed back out. They can pass through the air on a cough, a sneeze. They can potentially even pass on a handshake and get into another person.
Right. What about, like Lyme disease from ticks, et cetera? Some of the, I'm curious as to where, in terms of the science of all of this, in a big picture, the public hears about these diseases, obviously, after the fact, after it's been transferred, after it's been discovered, and begins affecting Homo sapien. Are we able at this point to see certain kinds or strains of diseases, or can we see them coming, that we see these diseases in animals and we need to be aware, and this seems like one that might be transferred easily? Or is there any commonality there at all?
Yes, there are some things that can be done. That's the $100 question. How can we see these things coming? How can we catch them earlier? For instance, the AIDS pandemic began because we were unaware of this disease for decades, and it had gotten into hundreds of thousands or millions of people before we even recognized it in the early 1980s. The influenzas emerge newly each year because the influenza virus is very changeable. It's constantly mutating and changing. That's why we need a new flu vaccine every year. So we never get used to these things. There's always a new one coming at us. So the scientists are watching for the new strain of flu. They see a couple of different kinds. They think, well, maybe this is going to be the one that spreads across the world. That's the one we should create a vaccine against. They're constantly watching now, and this is a relatively new thing, because they know that one of these things could emerge from an animal somewhere in the Congo forest or in Southeast Asia, and it could be so infectious and so virulent, so murderous, that it could spread around the world and be what they refer to as the next big one. It could kill millions of people. So they're watching, and they know there are certain kinds of viruses that are more likely to be that devastating, to be the next big one than others. For instance, the influenzas or the Sars virus came from a family called coronaviruses. So they're watching for those particular kinds of viruses with particular vigilance.
David, we don't want to be alarmists here. When as you're listening to this radio show and you're looking down at your dog who's laying asleep in front of your fireplace, you don't have to be afraid of them. But in general, in the scientific community, is it viewed that this issue and this health problem is getting worse? Is it getting better? Is it staying the same? Or is it just we know more, so we're more cognizant of it?
Well, first of all, I agree that it's important to reassure people that, if you have pets and your pets have had the usual immunizations, then your pets are not your enemy. Your pets are your friend, and these things are not mainly coming out of household pets. Not many are coming out of domestic animals. Mostly they're coming out of wildlife. Is it getting better? Is it getting worse? Well, this is a problem that's been around for a long time. It's not new. I mentioned the influenzas. The 1918 influenza killed about 50 million people around the world. The Bubonic Plague was a zoonotic disease that emerged from rodents and killed millions of people in the 14th century. So it's an old problem. It's been around forever. But it does seem to be getting worse. We hear a drumbeat of new names for viruses and other kinds of disease microbe that have emerged from wildlife are getting into humans. It seems to be happening more frequently now. I could rattle off a whole list of those names that we've heard about, beginning with Marburg and Ebola back in the 1960s.
Right.
They keep coming at us, and so it does seem to be getting worse, partly because we're watching more carefully, so we're seeing the things earlier, but partly because we are more vulnerable now. We are more abundant now, the human species. There are 7 billion of us. We're going deeper into the forests more disruptively than ever before, and the deep forests are where the biological diversity is, and where the biological diversity is also where the viruses are. So our activities, human activities, disrupting ecosystems, traveling around the world ever faster, more abundantly, moving our products around the world, those represent factors that make it more likely for viruses to pass into us, and once a new virus does pass into us, more likely for it to be transmitted around the world.
David, again, these diseases, as the world becomes smaller, and we have more and more contact, direct and indirect, with the wild animal kingdom. Is research showing are they carriers? They transfer to us, and then we are affected by it, or are these diseases killing animals as well? And I'm curious as that kind of sort of mortality rate, which one is necessarily higher?
Right. Well, here's another scientific term that sort of answers that question. The scientists talk about a reservoir host. A reservoir host is the animal in which the virus or the other bug lives permanently, unobtrusively, discreetly, and in most cases asymptomatically. How can they do that? Well, probably the viruses live in those animals quietly because they have been there for millions of years. Over the course of evolution, they have accommodated themselves to those animals. The animals have accommodated themselves to the viruses, so they live there. They don't reproduce very abundantly, but they do reproduce the viruses, and they don't cause symptoms. For instance, I mentioned Ebola virus killing chimpanzees and gorillas as well as humans. Well, that means that chimps and gorillas can't be the reservoir host of Ebola because it kills them too quickly. It would burn out. It has to live in some other creature. And that's one of the big mysteries in disease science right now, by the way. And what is the reservoir host of Ebola? Nobody knows. People know that the scientists know it's got to be there in the Central African forests where I sat at that campfire in some animal. But what? They suspect maybe a bat, but they don't have rock-solid proof that it is a bat.
Again, we're talking with David Quammen, one of America's experts on the transfer of diseases and various conditions from the animal kingdom to the human species.
I should say, Warner, that I don't consider myself an expert, but I've spent 6 years talking to the experts.
You're right. You're the conduit.
I'm the conduit, right? I'm the messenger.
Yeah, what are you, the reservoir host? You're the reservoir host of information.
I'm the amplifier host of this particular information.
Okay, very well. Diseases transferred by insects, by birds, by animals that stalk the earth. Were we to live or spend a lot of time in the ocean, would we get transfers from the fish as well? And and tell us a little bit about those animals that live underwater.
Yeah, well, they have viruses too. There are plenty of viruses in the ocean. And your question is very interesting. I'm curious about it too, but not much has been done. There's very little known about whether we might pick up viruses from marine animals. Generally, these viruses pass from species that are somewhat similar to us, rather than species very different from us. I mean, there are some exceptions to that, but we're talking about viruses that we get from chimpanzees, from monkeys, which are related to us, obviously fellow primates. Some of them come from bats and rodents, a little bit less closely related to us, but still they're mammals. When you talk about fish have their own viruses, but those viruses might not be able to adapt to humans. Obviously, we eat a lot of fresh fish, and we might be taking in some fish viruses, but you don't hear about that. I suppose that it would be more likely that we could pass a virus, we could receive a virus from marine mammals, from whales or dolphins, and by the same token, we could, I'm afraid, pass a virus to them, perhaps. But as I say, that's speculative. I haven't seen any scientific work on that.
Well, we have been doing this show in one form or another since 1996. We have never had a show specifically dedicated to zoonotics, which is the study of animal infections that transfer to humans. We have broken that barrier today with David Quammen, one of America's foremost writers on the subject and researchers for sure. And again, David, as we close out here, again, we're not trying to be alarmists here or sensationalists, but is there anything in particular on the horizon from your research and your work that you think we should be aware of?
Well, as I say, the scientists are watching for the next influenza. Influenza sounds like a mundane, old-fashioned disease, but in fact, it carries great potential to kill a lot of people, but we can get vaccines against it, so I certainly recommend getting your flu vaccine. And then scientists are watching for other things. There was an event this summer when a SARS-like virus emerged on the Arabian Peninsula, killed one Saudi man and put a Qatari man into the hospital. Only 2 cases, but boy, I can tell you, the scientists who study this stuff were watching those 2 cases very carefully to make sure to see whether that particular virus would start spreading to other people. So the scientists are vigilant. Their diagnostics are better than ever. As you say, I don't want people to panic. Knowledge is empowering, and so if people learn a little bit more about the scientific dynamics of this problem and the things that can be done to catch such emerging viruses early, then I think they will be reassured rather than frightened, but they'll be sobered by knowing what a serious situation this is.
Again, the work is Spillover, Animal Infections and the Next Human Pandemic. It's published by W.W. Norton and Company. The author, our guest, David Quammen. David, share with people, how can people find out more about this subject in general, your work, and also how to get a copy of the book?
Well, they can certainly get the book from Amazon, from Barnes & Noble, or from their local bookstore. My website is simply davidquammen.com, Quammen, and the CDC has a website. There are lots of places online that will tell you about the various different diseases. If you're curious about something, I'd say go Google up the CDC and see what they have to say about it.
Well, listen, thank you so much for sharing the information today. Fascinating subject that we don't think about. And again, just a heads up for our listeners. Again, this isn't the time to put the cat into a box and quarantine the dog. But it is a fascinating subject, and one that does affect our life on a fairly regular basis. And I appreciate your taking the time today to share some information with us.
Warner, thank you. Pleasure to talk with you and your listeners.
You bet. We'll be back with more right after this on Lewis at Large.